Hi everyone, welcome to KGP Talkie, and today we are going to take getting started with the TensorFlow and Keras, and in this tutorial I'm going to take fashion MNIST classification dataset, and in this overall lecture I'll be telling you how you can quickly get started with the TensorFlow and the Keras. This is really very simple, and we will be using here a Colab from the Google. And this Colab provides you a free Jupyter Notebook environment. Along with that, you can use the GPU and the TPU. The GPU is the graphical processing unit, and this GPU is used in the deep learning models for a faster training. All right. So as usual, I'm sure you know what's the TensorFlow, but just for the small introduction, the TensorFlow is a deep learning model framework, and this provides us an environment, or you can say a framework in the Python to train our deep learning model. There are other frameworks as well, like the MNIST and the PyTorch, but here we will be using the TensorFlow. And the Keras is also a high-level wrapper for the TensorFlow. This TensorFlow works in the three parts here. The first is the pre-processing the data, then the model building, and then the training and the estimation or evaluation of the model. So moreover, we will do first the pre-processing of the data if you have unprocessed data. But we are going to use here a fashion MNIST dataset. That means this dataset is already pre-processed dataset. So you may not need to do any further pre-processing. So we will quickly jump to the building the model using the TensorFlow and the Keras in the Python. And then finally we will do the training and then the model evaluation. So this one is Google Colab, but before getting started with this, you need to go here inside the runtime, and there you need to change this runtime to GPU. The GPU is the graphical processing unit, and this GPU is used in the deep learning for a faster training. All right, then you need to save it simply. Let's go ahead and learn something about the fashion MNIST dataset. This fashion MNIST dataset contains 70,000 grayscale images. The grayscale images, that means this is the black and white images, and there are total 10 categories in these images there. And the size of these images are 28 by 28 pixels. That is definitely a quite low pixel size. But the advantage of having this 28 cross 28 is the total overall size of the dataset is also quite low. Here is the link of this fashion MNIST, where we can go here on the GitHub, and on the GitHub you will see there MNIST like fashion product dataset here. All right, this one is the fashion MNIST here. This is the grayscale images here, and there are total 10 classes, as we discussed earlier, that those 10 classes are mentioned here. There are t-shirt, trouser, pullover, dress coat, sandal, shirt, sneaker, bag, and the ankle boot. The 9 number is the ankle boot, 4 number is the coat, and so on, right? And these are some of the example how you can use this, like the MNIST, Kaggle, PyTorch, and the Keras, all those. Although here is the example for the Keras. You can visit the keras.io to understand what's the Keras in a very much detail, but we are going to just leave it here. So the Keras, you can say that, I mean, for your understanding, the Keras is high-level API, which is wrapper for the TensorFlow. All right. So this Google Colab automatically have there the TensorFlow installed on the Google Colab. That means you do not need to install the TensorFlow on the Google Colab, right? Otherwise, if you don't have the TensorFlow, I mean to say that if you want to reinstall the TensorFlow, you can simply run this code. It will install the TensorFlow in your notebook. All right, so I'm going to just skip this part since we are not going to install the TensorFlow. So once you have the TensorFlow, you can simply import the TensorFlow as the TF, and then also we can import the Keras module from the TensorFlow. So just run it. Once you first time run it, it will start allocating a machine to you, and then finally it will connect to a GPU, a backend GPU provided by a Google. And this GPU is free of cost. You will not be charged anything here. So this is the great advantage for us to get started with the deep learning. And you can test here the TensorFlow version. It says that this Google Colab environment is using a TensorFlow 2.5 version. All right. And whenever you are watching this video, this TensorFlow version might change, like the 2.6 or 2.7 or so that. Thereafter, you have here other Python packages which we will be using throughout our video lecture. Like here, we will be importing a NumPy as NP. The NumPy is like the mathematical tool, and the mathematical computation is being done in the NumPy. This is like a MATLAB, you can say. And the Pandas is also a mathematical tool, but moreover, it is like an Excel sheet where we will be visualizing the data in the form of the tables, and then we can also do the mathematical computation in the form of the table to table like that. All right, and thereafter the matplotlib.pyplot as the PLT. So this matplotlib is a visualization library in the Python. We will be using this matplotlib to visualize our plots there. Let's go ahead and run this. Thereafter, we have here this MNIST. This MNIST says that here the Keras.dataset fashion.mnist. All right. So the Keras is the module, and inside the Keras there is the dataset module, right? So, and you can simply, I think from somewhere, otherwise you can simply search here this Keras dataset module, right? Something like this maybe. So here this the Keras dataset module. You get all these dataset, like you get the MNIST, CFAR, 110, IMDb, all these dataset are there at the Keras. All right, perfect. Once MNIST dataset is imported in your notebook, you can check the type of the MNIST dataset, right? Let's go ahead and run this. The type of MNIST dataset is a module, and out of this module, we are gonna get here our training and the testing set. So the way this MNIST dataset is organized, that we can check it from here. So this MNIST.load says that it is the two-dimensional list is there. So in this two-dimensional list, along with that, this is also in the form of the tuple there, right? So what's happening here? What we can do, this you see there, this is the tuple there. So what we can do here, we can actually read this in the form of the two tuple. So this one tuple here, another tuple. In this tuple, we are going to take here X train and the Y train. Now you can consider that this one is the X train data. And do you consider here, do you see there, this one is kind of the tuple organization here. So it is organized in the form of the tuple. So till now it was the X train, and thereafter this array, which it seems to be 1D array, that is the Y value. That's the Y train and the Y test. That's what it's happening here. So just to simplify this, we are going to simply, where were we? Yeah, here. So just to simplify this, we are going to simply run this. Now, once you run this, those two tuple will be separated in these two tuple, and out of those, the X value will go into X train and Y value will go into the Y train, and then X test and the Y test. Let's go ahead and see the shape of the train and the test data set. So it says that the training data set shape is total 60,000 number of rows are there. And similarly, we can check it for here X test data set. Just run it. Now what do you see there? This one is the 10,000. So the total, we had 70,000 rows at the data set. Out of those, 60,000 are being used in the training set and 10,000 is being used into the test set. All right. The maximum value here in the training set in the X train is the 255. The reason is because this one is the black and white. This one is the black and white image, and the 255 means there is a very bright color. That's the white one. And if it is the 0, then that is the dark color, which is the black color. So all the value are in between 0 to 255. because the 8-bit, if you represent 8-bit in the binary format, you represent there 8 1 there, right? 8 consecutive 1, that's the 255. But the deep learning model works well if the values are in between 0 to 1, right? So we are going to convert this value, this scaled value, from 0 to 255 in between 0 to 1. So the best way to just divide it by 255, right? So the maximum value will be 1, and whatever the value is in between 0 to 255 will be divided by the 255. So the overall value will be then 0 to 1, and in the deep learning model, that's the best suited value there. All right. So this, the mean value doesn't show any significance to us. So let it be. The white train here you see 0 to 9. If you remember, I told you earlier that there are the 10 classes, and those 10 classes are represented at 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the total 10 classes are there. And the classes names are here: the top, trouser, pullover, dress, coat, sandal, shirt, sneaker, bag, and the ankle boot. You can compare it from here as well. So here it says that the label 0, 1, 2, 3 like that, the shirt, which is actually the t-shirt actually, and then the trouser, pullover, dress like that. All right. So that the t-shirt at the top, actually that one is, right? So that's what we have here. This one is the class name. Thereafter we have, just run it. So let's go ahead and explore this data a little more, how it is being shown in our data set. This data set, from here we are downloading. Now we need to verify that are we seeing a correct data set or not. So basically here the training data set have total 60,000 data set. As usual, we see that the 28 cross 28, this says that the 28 cross 28 pixel for each data set. Thereafter you have the xtest.shape, and this one have the 10,000 value, which we already know. And we are going to simply here see one image, right? So we can select randomly any image here. plt.figure, it will first create here a figure template or a figure canvas here. Then the plt.image show, this will show values in the form of the image. Thereafter this plt.color bar will show this color here. All right, just go ahead and run this. So once you run this, you will see this particular image. But moreover, if you change this value, you can see here any images, like 10 is here, something like this. And if you change it to 12, you see something like this. This seems like a sandal. All right, so that's how you can visualize these images, which are represented in the form of the numerical value. And if you just take this value and print it here, you will see that that value is represented in the numerical format, right? Do you see this here? But this value we are actually seeing there in the form of what? We are seeing in this value in the form of image there, right? With the help of matplotlib library. All right. So there is the Y train, which we already know. Now, as we talked earlier, that now we are going to scale down our values from 255 to in between 0 and 1. The reason the deep learning model works best if values are in between 0 to 1. So that's what we are going to do here. So this value is scaled down to 0 to 1. Now if you check the maximum of these value, which you can say this np.max and then xtrain, you will not see any value more than 1, right? The reason, because we have scaled down these values by 255, right? Now let's go ahead and see these colors again. Now you see the color again here, there is no change in the color scaling and other thing. I mean, only the color scaling is changed, but overall color, if you see this, the color will not change much there, right? I mean, it's not changed, it's not changed at all, right? Do you see there and there? Only the scale is changed. Now scale is 0 to 1. Earlier it was 0 to 255, right? Now let's go ahead and build the TensorFlow model. So here we are using a TensorFlow 2, and what we need while building the model, we need a sequential layer, and thereafter we need flatten layer and the dense layer, right? We're not going to use here any convolutional layer. This is just getting started video. So I'm going to use here deep neural network, or just you can say the fully connected layers, or a dense layer, right? So the fully connected layers and the dense layers are the same thing. There is no change in between these. And there are the deep neural network. When a hidden layer in your neural network becomes more than the 2, then that becomes a deep neural network, right? So we are importing here a sequential layer from the TensorFlow.Keras, and we are also importing here a flatten and the dense layer from the Keras and layer. Just go ahead and run this. Thereafter, as I told you that if the hidden layers, all right, if the hidden layers becomes more than 2, then that becomes here. You see this, the hidden layers are more than the 2, then this becomes a deep neural network, right? So how it is working here, there is the model. The first is the flatten layer. The input shape of the flatten layer is the 28 cross 28 because our image size is a 28 cross 28. That's why we need to give this particular input shape to our model. Thereafter, we are adding here 2 hidden layer, and these 2 hidden layer have 128 neurons there in first layer, and in second layer it again have 128 neuron, and these are the fully connected layer, or you can say the dense layer. And then finally at the last stage we are again using here a dense layer, but you see there is the 10. This 10 says that the 10 classes, and now this activation function also changed here to the softmax. This activation function actually introduces the non-linearity in our model. That's how this becomes a distinct from the linear model and this the deep neural network model, right? So this activation function actually transform our data non-linearly so that it can create a complex model and the accurate model there, right? And then the final stage, the activation model is here the softmax. So basically it will be predicting the probability of being a particular class out of these 10 neurons there, right? So just run it, and then finally you can print the model summary here. This model summary says that we have total 118,282 parameters, and out of these all these parameters are trainable, right? That's mean while training our model, all these parameters will be trained. If there is any weight change, that weight will be assigned to these model weights, right? Let's go ahead and do the model compilation, and then finally we will train our model, and thereafter we will test our model. So this the model.compile, with this we are going to actually provide the optimizers and loss function and also the metrics or evaluation metrics to our model. So the optimizer, we are saying that we are going to provide here ADAM optimizer. This ADAM optimizer is stochastic gradient optimizer, this one, and there is the loss function. This loss function is sparse categorical cross entropy loss function. So whenever you have output parameter as a y, which is like the 0, 1, 2, 3, 4, 5 like that, that's mean if you do not have one hot encoded output parameter, that's the training parameter, or you can say the target parameter, then you can use this sparse categorical cross entropy, and the metrics which we are going to use here, that's the accuracy. That's mean our model will be optimized on the accuracy, right? Let's go ahead and just run it. Thereafter we are going to do here model.fit x train, y train, and the epoch is 10. That's when this model is going to run for 10 epoch and it will do the training. All right. So each of these epoch, it is actually taking the data set there and shuffling internally the data set, and then finally it is training it 10 times, right? And every time whenever there is error with the method of the back propagation, it is changing the weights inside the model so that it can minimize the total error to increase the accuracy. All right, so that's how it is working. Now you see here with this only the 2 fully connected layers or a dense layer, we are able to get the accuracy of almost the 91 or 92%. with this model, it's not the bad accuracy, but in terms of the accuracy achieved on the MNIST Fashion dataset, that's a low here. But still, if you use here the convolutional network or other network, then definitely this accuracy can go up to the 99% or even 100%. Since this one is the getting started video lecture, so we have just used here without any model optimization, just two fully connected or two dense layer, just to quickly test our model. So it says that we have total accuracy of almost the 91% on the training set. Now let's go ahead and see how much accuracy we have on the test set. So for the test set, we have accuracy of the 87%. So the moreover, it is saying that this model is actually overfitting. So to avoid the overfitting, there are other methods to avoid that, like the regularization. You can add the dropout and other things, which I'll be discussing in the coming lectures, how you can add the dropout and the batch regularization and how you can use the convolutional neural network. Those things I'll discuss in the separate tutorial, but just for getting started, you can definitely use this particular model and you can test your model on your particular data set. Let's go ahead and try to get the accuracy here. All right. So actually, yes, the accuracy was already there. So this one is here, the another method to get the accuracy. So this method is like getting the accuracy with the help of the prediction, and then the comparing it with the test set. That's the true value and the predicted value. This one is the another method, but you can simply also use the model.evaluate just to pass X test and the Y test to evaluate your model. And the Y pred is something like this. You see there. All right. So if you want to check that what it had predicted on the X test value, that's mean on this value, you can simply call here model.predict, and then you see this, the predict is actually, this is the two-dimensional array, right? The two-dimensional array of the size, how much size it's going to be? This is going to be the 10,000, because the X test is X test contains total 10,000 data set. So this is going to be the size of the 10,000, and each data set have a 10 classes. So if you count these value, this will be the 10 value, and out of these 10 value, there would be one value which will be having highest number. The reason is because it will classify a particular object or a particular data set in one class, right? So let's say if you check this pred 0 and if you count this 1, 2, 3, 4, and 4 into 2, that's the 8, 9, and the 10, right? This corresponds to the 10 classes which we had earlier, right? The classes, if you remember here, this one, the class names, right? The 10 class names are there. So this says that the probability of being as a top, and this says that the probability of being as a trouser, and this says that the probability of being a pullover, dress, and then coat. Thereafter there is the sandal. Then this says that the probability of shirt, sneaker, and then this says that the probability of the bag, and this says that the probability of the ankle, right? So that says that this one have highest value, which is 0.98. And if you remember, the zeroth data set in our X test data set was actually ankle boot there, right? We will test that later on. So moreover, if you want to get the maximum argument here, that's mean which argument value is the maximum, you can simply get it with the np.argmax and then np.argmax pred 1, right? This is the pred 0 and the pred 1. That's mean the pred 1 is this one, right? For second one, right? There it says that the maximum value, which one? This one, right? There, the second one, right? Do you see this one? Second one, that's mean 0, 1, 2. The second miss, which is actually the third one, right? So let's go ahead and check this, the 0, 1, which we saw the previously. This is the ankle boot here. And if you want to check the class of this ankle boot, you need to pass here X test 0. And then we need to reshape this with the 1, -1. The reason we want to reshape it, because we want to make it into the two-dimensional array, because our model was actually trained for the two-dimensional model, right? All right, so thereafter you see there is the pred here, and then this pred, you run it. Now you get here this 9 value. All right, and thereafter what do you get here? This the class name for a pred. It says that this one is actually a ankle boot, right? Perfect. Thereafter you see here how you can save your model. You can simply run here model.save, and this is going to save your model here. All right, thereafter this first saves the architecture of model, and this one saves the weight of the model. All right, thereafter you have here this the Keras.model load model. Then you can load the model as like this, and then you can use this model one to predict here, right? So once all these models are saved, you can simply download these model from here, right? So this model is saved here, the architecture, and then there is the weight of the model is saved there. You can simply download the files here, and then you can use it later on. All right, so this is all about in this lesson. Thanks for watching, and if you like this video, please subscribe this channel. Comment below if you have any doubt. You can comment below, and also like this video. All right, guys, check out this clothing brand which promotes a sustainable fashion. They have a really excellent collection of clothes, and the top of it they do a free shipping across the India. Clothes quality and the durability is quite good. Link is given in the video description, and you can check that. If you want to buy a particular cloth, you can definitely buy it from here. And another good thing is that they are running currently a sale, so you can really get a quite good amount of the discount on these clothes. Links are given in the description. Please check that.